First off, I want to say I greatly appreciate everyone joining this evening. As we're getting started, I'd like to cover the chat session disclaimer. This live chat in the Codings Talk series does not represent the opinions or strategies of AkzoNobel International. And additionally, I make every effort to provide accurate and up-to-date information from the global protective coatings industry. Despite this care and attention, it is reasonably possible that the content and chat conversations within this live broadcast may have content that is incomplete or it could be incorrect. The information and chat conversations on this live broadcast are offered without any form of guarantee or claim to accuracy. There is no liability accepted for the consequences from such errors. No agreement shall be reached on the basis of such errors. And recording, distributing, and any other use of this live chat is not permitted without written permission from Jim Kunkel. That's me. And also, too, for everybody to know, I am recording this session's audio for rebroadcast and to have an archive recording. Okay, before I introduce the speakers for this evening, you can participate. This is an open forum live chat. You can participate. It's real easy. All you have to do is use the raise your hand feature. And when you raise your hand, I'll invite you up to the stage. You can participate in the conversation, ask a question. And then when you're done with your comment or question, mute yourself. And then what I'll do is I'll probably end up moving you back into the audience after that. But like I say, all you need to do is raise your hand. And also there is a reaction so that if you like the stuff that's being said, you can give us a thumbs up. You can give us a little chuckle there. You can give us a heart, which we would greatly appreciate. And that's it. So let me go ahead and first talk about the topic. We're going to be covering robotic technologies for the coatings industry. The two speakers I have tonight are absolutely phenomenal speakers and also two subject matter experts. First, I'd like to introduce Ian Rowell. Ian, would you like to go ahead and give your bio and your background as a subject matter expert for everybody?
Yeah, sure. I spent 50 years in this protective coatings industry. I started straight from school and was fortunate enough to spend some time, first 10 years in a protective coatings laboratory, learning all about paint, how to put it on, how to develop paint. As my career progressed through different stages, I eventually moved to North America 30 years ago. Spent time in different roles from marketing, sales marketing, business development. About 10 years ago, I had the great opportunity to go and live in China for 4 years, then back to Europe for another couple of years, until I came back here into North America, all the time in protective coatings and marine world. One thing I learned, I became very passionate about technology, what it does and what it does for people. I've retired, but I'm keeping an active role in following technology and looking how technology impacts and trying to give back to the industry from my years of experience.
As your bio says on your LinkedIn profile, passionate about new technology. So glad to have you this evening. And also, too, we have Norm Spence, who's the CEO at Spence Corrosion Services and CSR Robotics. Norm, welcome.
Thanks, Jim.
If you would want to give your bio as well, I appreciate that.
Yeah, my name is Norm Spence. I've been in the corrosion industry for the past 15 or 20 years. We created our company here in Leduc, Alberta, Spence Corrosion Services, specializing in blasting, coating, and rubber linings of acid tanks throughout Western Canada. We've been doing that since 2010, and approximately 4 years ago, we had a small incident with one of our sandblasters, and that got us into robotics, and we wanted to see how we could create a safer, more efficient way of blasting the internal of the vessels we were working on. And out that spawned confined space robotics. So we've been doing that for 3 years, and just trying to recreate a variety of robots that can work in confined spaces to blast, coating inspections, and a part of AR training.
Excellent. In addition to us talking this evening about robotics use for surface preparation coating application, we will talk about drones as well. And then also the last topic we'll cover is going to be technologies for the modern coatings inspector. We'll talk a little bit of built-in future AI that's going to be coming up on the horizon, and also talk about drone inspection and assessments both aerial and underwater, and then also digital inspection reporting. But let's go ahead and kick off the discussion, and let's talk about robotic surface preparation. I've seen, and probably a lot of individuals in the audience has seen in the field the use of both human crews and then also tied in with robotics as well. So one of the things that I've really liked about when I've been in the field and I've seen robotic use is that in some cases it's employed or deployed, excuse me, in certain projects that can reallocate the human side so that blasters can go work on other projects that might require a little bit of finesse, detail, or maybe a little bit more intensive of a project. But also, too, I've seen some projects where there is a combination done of robotic and human blasting done at the same time. Norman, when it comes to your experience with magnetic crawlers for surface preparation robots, what is the big benefit of having robotics when it comes to surface preparation?
Well, I mean, once we can remove a human or a human away from the dark and dull, dangerous work, that's the main goal for the contractors and the owners that we're working for. And so, putting a robot out in front to perform the surface preparation, the sandblast dust or the abrasive dust, the high pressures, the noise. It allows us to remove the human to operate the robots rather than the humans performing that work. And automation in the last 10 years of automated blasting surface preparation, that automation has allowed companies such as mine to use that knowledge to become robotics, to move to robotics surface preparation.
Ian, when it comes to the production with a robot, what's the advantages of having something that can be programmed?
Well, you got to, I was just reflecting back on the original comments there because that automated blasting has changed industries. If you think that every ship that's going around the world, the original surface preparation was done by a very simple robot, an automated blasting unit followed by an automated spray unit, and that changed how ships were built. It changed the speed of production and the fact that the automated line could work 24 hours a day. So if you're looking at fairly round, reproducible surfaces that you can actually set a robot or a production surface preparation machine onto that, your production time will be significantly quicker than what a human can do. Not only the fact that you don't have less downtime, you can run for longer hours. So that when you have the right type of surface, the robotic surface preparation is a step forward in terms of productivity. Never mind what Norm just mentioned about the overall issues with safety.
No, that's a very good point on that. When you're looking at efficiencies and production rate, you're looking at something that would, have an operator that would have a joystick, for example. Some of it can be programmed as well. Is that correct, Norm?
That's correct. Yeah. So where we're leading to in the robotics industry is taking what we've learned from these automated systems that can do large, flat ship hulls, tank shells, tank roofs, and moving that technology into robots that now can do more complex structures such as I-beams, nozzles, and other inside ballast tanks, very complex structures where these robots can be programmed to follow a certain path or a 3D model. We can set that out and allow that robot to follow a certain path rather than just a simple a shell wall.
And in addition to doing field work, there's also robotics used for shot blasting as well.
Absolutely.
Any of you have any familiarity with the shot blasting robots?
Yeah, I do. I mean, I'm going back to the 1980s. I was working with a company who had a shop doing prefabricated buildings, the type we see all over the place, which is fairly standard pieces of I-beams, H-beams. They set themselves up a blasting robot to blast the beams. Very, very effective. I've seen that type of unit used all over the world. But what really struck me about this company did in the 1980s was they then programmed a spray machine. Paint is very easily, but then they moved into fire protection. They were spraying intumescent fire protection in the 1980s through an automated robot for a prefabricated building. Now that worked for them because prefabricated buildings, as Norm said, are very replicable structures. They're usually all the same. The beam sizes and dimensions can be replicated, so you can program something. As structures become more complex, as we see something in offshore or skids that are usually unique every time, that's when the difficulties of handling robotics comes into play. More complex, more difficult.
In addition to doing dry abrasive blasting, you can also do wet abrasive blasting and also hydroblasting as well. Let's move into the hydro surface preparation side. And also too, I'd probably also like to mention that there's hydro demolition robots that are utilized for concrete if you need to do deep blasting to kind of take off problem areas, let's say sections of concrete, to be able to go deep into it, to be able to resurface that. What are the benefits, and then also too, what are some of the opportunities out there, let's say, when it comes to hydroblasting with robotics?
Yeah, Jim, the hydroblasting robots, very similar to the automated blasting abrasive robots. They can crawl on very large spaces, use ultra high water jet or high water jetting pressures to remove either coatings or cleaning a ship hull or a tank shell. As you increase or decrease your pressures, you can remove the old coatings right down to bare steel. However, you run into the issues of a drip ring or a staircase on a tank or a staircase on a shell of a ship. There are certain structures that just can't get around or over. And again, then we're back down to having humans get into those areas.
Yeah, the use of UHP really came up about 20, 25 years ago in the marine world. Dry abrasive blasting in the dry dock. You had all the dust flying around, cleaning it up. So the dry dock owners and eventually decided there's a better way of doing it. They convinced the ship owners that you could remove coatings. One of the big challenges was convincing the ship owners that you can paint a rusty surface, which actually turns out to be a better surface to paint in a lot of instances. That developed logical step was into robotics. Probably the first ones I saw were about 15 years ago. That has continued in various parts of the world, but what's really driving that around the world now is environmental. The changes that we're seeing in China, Germany, Brazil, basically saying you can't blast in a dry dock, is spawning all sorts of robots of different speeds. I've now seen robots that can grind wells, robots that can do stripe coating, robots that can continue in a full robotic operation. But the environment legislation is driving that very, very quick. But the big step forward was people wanting to eliminate the environmental impact of waste abrasive, the dirt, and the impact that had on the dry docks. So the marine industry, to my mind, drove the UHP, which has now grown into all sorts of different applications across the wider industrial area.
That's a very good point, Ian. And then, we talked about with robotics too, there's also robots really when it comes to surface preparation of all sizes. You might have some that go inside interior pipeline that might go in and do some spot work or some basic prep work as well. So, hey guys, anything else that we want to cover regarding robotic surface preparation before we go into coating application? Did we miss anything?
I think
there's.
go
ahead, Jim.
Go on,
I think there's a lot of with all the robots, from drones to abrasive blasting, surface preparation, coating robots. They're still in their infancy stages, and I believe that what we're seeing today is just the first starts of the first generation of these surface robots to help us prepare a surface for coatings. And I think we're going to see some really good technology come out over the next couple of years.
That's exactly the same point I was making, Norm, was going to make, that, the technology we see now is really in its infancies, and you can have all sorts of analogies from anything where cell phones have evolved, anything. Things will change. But when the change is being pushed by an owner because they can see the advantage in cost and productivity, the environmental impact, the safety impact, they will push people to look at it, to explore it. And that's when people will start looking, developing new ideas. And the best owners we have out there will realize the first time they do a job, it might not be the right job. It may not work properly, but they believe enough that allow the industry to develop. And when we look back in robotics in 10 years' time, it'll be very, very different.
Yeah, and to kind of look at the aspect of as a contractor, the use of collaboration between robotics and human work is that now you have the ability to go after potentially new business if you're going to be doing certain structures that a three-person crew, a tender, someone kind of helping out, and a person operating the joystick. They're going to be able to do work. And then, as I mentioned earlier at the beginning of the broadcast, about how you could take your teams, your workers, and be able to deploy them on other type of projects as well. So there's an advantage, I think, for the owner, and then also for the contractor. Norm, anything related to value to the contractor of utilizing robotics?
Oh yeah, I mean the contractor, especially in today's marketplace after COVID, has affected all of us. Um, Robots will allow a different skill set to be able to perform the work. So we're seeing a lot of females join the workforce that could blast or use a blast hose because it's robotically performed. We're training them on how to use a computer program rather than holding a blast hose for 10 or 12 hours. So we're reaching out to non-traditional employees, big men, to perform the work. I think you're also seeing the efficiency of some of the robots. The robots can hold a blast hose all day and perform the work repetitively and efficiently all day long, where a human will tire with time. So that type of efficiency translates right into dollars. So savings on blast media, savings on fuel for your compressors, and increase in a production anywhere from a little bit of an increase to three times an increase, depending on the robots being used.
I think an interesting discussion I had recently with a contractor was, think this is like the foreman of a contractor, and he was worried about people in his team. He was very protective of, and people might not having a job. But what it actually worked out was you need the same number of people in the crew, but their jobs and the work they're doing will be different. So it will be the same number of people, but they need a different skill set. And that was once he got that in understanding, he realized and became very supportive.
Yeah, Ian, I would 100% agree. So far, what we've seen in the market is it's a shift of workers from, we call it a shift from doing the work to doing the robot, in the sense that now instead of a person physically performing the abrasive blasting and that type of work, they're actually monitoring and using the robot from a computer program,
Yeah.
or flying a drone, or operating a joystick. So we, as a contractor, you haven't lost workers, and I believe the contractors that are taking on robotic technology are getting more work, which hence you have to hire more people. I haven't seen a loss in or a decrease in employees.
I can imagine, Norm, on your future interview sheet, how many hours do you spend on an Xbox growing up as an indication of how good they might be on a joystick?
Very, very true.
All right, let me. Actually, we have somebody who wants to join us up on stage. Okay, let me open up your mic here. Profile to speak, and there you are. Okay, your mic is open, sir.
Hey guys, good evening. Just to piggyback on what you was just saying about having Xboxes and the money you spend, I'm curious to see how if any organizations such as NACE or SSPC, anybody with application courses are going to try to regulate this or give out certs to justify that someone knows how to, I guess, use this equipment to try and create like a common practice kind of thing. Because of course, I don't know if you guys have experienced any user area lately, but same thing with just regular, airless spray or the conventional ways that we do it now. That's recommended practice of doing the application. I wonder if they're going to come out with maybe some standards or certs that's obtainable in the future.
Yeah.
Good point, Antoine. I believe that AMPP and other organizations in Europe, Frosio, and other organizations are going to have to work with a multitude of robotic companies around the world and come up with robotic training programs. I also believe that they're going to have to look at their standards and be able to change some of these standards. And I won't say there won't be drastic changes, but they're going to have to be a slight change because some robots will be able to still abrasive to an SSPC PA SP5 white metal blast. However, it's how it gets there or how it's tested may have to change in the wording of those standards. And I think AMPP in our North American standards is going to have to work with drone companies, crawling companies, water jet companies to come up and make those programs within those standards. And I'm hoping this year is a start of that talks to AMPP.
That's a good point, Norm, because ultimately the surface preparation standard won't really change, but it's, as you correctly said, how it's get there, some of the wording behind there may well have to be updated. Same with some of the workers' training. It's still going to be the same type of equipment with the blast nozzles. It's going to be the same type of abrasive, which will still need maintenance, will still need to be looked at, but it will have to be done remotely rather than somebody who's holding a nozzle and feeling something different.
And I also believe that there are some organizations that are working with robots that are going to, I believe they're going to try to design some training facilities, hopefully possibly in Houston, Amsterdam, up here in Canada, possibly somewhere on the East Coast, where companies such as drone companies, crawlers, our companies can come set up training facilities and then invite employees from around the world and other contractors to come and work with the robots, learn the robots, get certified with those robots, so they can go back to their own states and businesses and be successful at them.
And then have owners and clients respect it. You know what I mean? Yeah.
Absolutely.
I feel that.
So, Norman, let me ask you this question when it comes to your experience, and Ian, you probably have this experience as well. You have robotic work being done, let's say on the surface preparation, you have a NACE inspector, SSPC inspector, AMP inspector, whoever you have out there for ASIA. Is there any potential issues or challenges when it comes to where we currently are with inspection, training, certification, education, and robotics on projects?
For sure. Some robots, I'll use a crawler or a drone robot. If a drone is flying around performing the work, now how does the third-party inspector get up to that same area to perform the inspection when AMPP has trained the third party? They have to see it with their eyes, use a dry film thickness gauge or a surface preparation gauge, salt gauge to do chloride testing. How is that third party going to reference a standard when it's now being performed by a robot? So if a robot is crawling and performing the the inspections, is that going to qualify or quantify the inspections to the owner when the third party, there's no direction for a third party? Is he or she allowed to do this? Can I look through a video and still quantify the blast SSPC, SP5 white metal blast? Can I still quantify that? I think there's some gray area, and that's what has to work out, hopefully between owner, the standards, and the inspectors and contractors.
Yeah, a lot of my experience, especially, has been on the hull side or some of the offshore side, when they've used robots for the ship's hulls or for some of the legs on an offshore platform. The inspector's effectively been put into some type of man lift and gone and done his inspection. So if you look at an overall project and you're reducing the time a person, manpower at height by 85%, the inspector's time is usually 100% at height because he's inspecting at height. As Norm alluded to, there is a leap forward, especially with the drone side, where the drones can take a video, can take the dry film thickness, can measure salt content, but then how is that reported? How is that fit to the standards? That's a leap forward, because in my experience, at the moment, the inspectors are still being put at height to do their inspection.
No, I appreciate. Go ahead, Norman.
Yeah. Also, again, very similar as we talking. As an inspector, you're inspecting the robot through, inspecting the surface through a robot or through a video camera. If we can quantify it, is there going to be, what type of video camera does it have to be looked through? Is it 120 views? Is it 360 views? What type of do we have to have still camera pictures or videos, and will they suffice to meet our inspection standards?
Very good. So let's go ahead and move into on the coding application side. I remember, back in the '80s, seeing all the videos regarding the robot, painting robots and everything. But that technology's come light years ahead in the past 15 years. Ian or Norman, anything that you would want to talk about regarding painting robots, including some of the drone painting units that we're seeing pop up?
Yeah, I'll go with that one, because I started a presentation off a while back and said, ask the audience, how much of the world's paint is put on by robot? My estimation is 25% of the $120 billion of coatings that's sold every year is currently put on by robots. But then robots are usually in car facilities, they're in powder coating lines, they're on OEM equipment. So there's plenty of robotics technology out there. Some of it's very sophisticated, some of it works accessibly well because some of the production rate have been fantastic. The issue we've had in the industrial field is transferring that knowledge from inside a shop where things are controlled to the field, whether it be an offshore platform, whether it be a petrochemical plant, whether it be a marine new construction yard. With the biggest issue being overspray. You try to apply something with a spray gun, there's a bit of wind around, it goes all over the place. We all know that. The shipyards have tolerated it. You've seen some great pictures around. If you're painting a ship's hull, you can see the paint drifting and which way the paint is spraying. And you've seen the same thing on offshore platforms when people are working, the paint drift. Now, that's not always acceptable. The challenge has always been, there's plenty of robots, there's plenty of robot equipment, there's plenty of controllers, but how to control the overspray. And that's why we're seeing technology emerge at the moment. Some work's been done from a startup company in Holland. They used aeronautical engineering techniques to look at how the flow of spray happens as it's been sprayed, how it's hitting the surface, and how to be able to pull that effectively away from the surface and collect it, so you can virtually eliminate overspray. It's a step forward. It's a technology that's starting to prove itself, but it's the only way that you can do work outside is collect the overspray, and that's where the challenge is.
Let me bring Tony up onto the stage. Tony, hold on one second. And okay, Tony, your mic is open. Oh, you have to unmute yourself, but you're available to talk.
Well, Ian, this will be a blast from your past.
I was just talking about you the other day because I was chatting to Benny Carter over a coffee.
Hey, Ian, Todd had sent me the link today. As you know, I'm working as a coding specialist for Nucor Steel now,
Right.
overseeing the coatings in their shops. We have a FANUC robot that has been down for 3 years, and my biggest fright that I have of robotic spraying outside of automotive um, and other automated spray systems is that I cannot get the equipment serviced.
Yeah. Absolutely.
Nobody.
Absolutely.
If we put it into a maintenance system, then they're willing to keep it up. It wasn't. I got to get the equipment up, and I'll be honest with you. I've got a $6 million robot. I'm encouraging Nucor just to blast the paint off of it, cut it up, send it back to the scrapyard, and send it back to our shop under a new life. Any feedback on that since you're specializing in this now?
Absolutely. I know. I use the adage. I say I've been advising a couple of companies about globalizing, and my analogy to them was, I love Audi cars. I've got a couple. But if I didn't have a service center just down the road that's fully equipped with knowledgeable people, I would never buy an Audi car. So I've been saying to anybody who's trying to set up in this industry, it's great having the technology, but your success will come from the service and support that you have behind it. You need multiple machines in place. You need qualified technicians in place. You need people who can be on the phone within 24 hours, the type of service we would expect any day of the week. A one-off machine is worthless. It will probably never work. You've got to have a sustainable business with multiple machines backed by quality service and technology, or you will fail. And I've been very, very clear in that to anybody. I've said the life of your business will directly depend on the quality of the service you will give. If you don't give that, you won't have a business. So I've been pretty direct on that one, Tony.
You've always been direct with me, Ian.
Really? You got to have it. You got to set it up. It's great taking the machine, showing it out to somebody, demonstrating it. That's fine. Somebody might buy one machine. That's fine. But it's not a business. The business is when you have multiple machines, you have all the service and backup, you have all the spares, you can react within 24 hours, you've got redundancy in the number of machines. So if something goes down, you can put another machine in place within a limited number of hours. That's a business. Without that, you don't have a business.
I appreciate your feedback on that. I think I still have your contact information. I'll be in touch with you.
Okay, Matt.
Thank you.
Good to hear from you again, by the way.
You too, Ian.
Yeah, thank you, Tony. Appreciate that. Okay, so we talked about robotic surface preparation. We talked about coding application. Let's go ahead. I'm going to move into technologies for the modern coatings inspector. And I'm not sure in the audience if there's any health, safety, and environmental people. But one of the things that I've seen an increase in the last number of years, but also future projection, is related to project site environmental and conditions monitoring, where you actually have more real-time monitoring and alarm systems that are built in there, checking for temperature, humidity, wind, everything that's important for projects when it comes to environmentals and conditions and things like that. The other thing is when it comes to air sampling and monitoring systems with alarms as well. Checking for any type of doing air sampling, but also to alerting if there's any issues related to into contaminations and things like that. And then the other thing is the data loggers, collecting all this information, and that these systems can be wired. They can be a Wi-Fi in remote locations. They can be satellite based, and then also too, they come with a lot of these systems come with APIs, which basically allows other integrations into apps or other type of reporting systems and things like that. The next thing I wanted to talk about is related to drone inspection and assessments. When we think about with drones inspections and assessments, you have aerial drones that can be done, but also underwater. And what I mean by the underwater is if you're inside of a tank, water tank, for example, and you're able to utilize the drone for observing and also to doing some checks on conditions and things like that. So there's a lot of very robust systems where you can utilize these aerial systems and also too with underwater as well. Ian or Norman, do you have any experience when it comes to drones or robots, let's say, to do assessments or inspections when it comes to coatings?
Yeah, for sure. Our company utilizes both a coating inspection crawler, magnetic crawler, to perform visual DFTs and holiday inspections of coatings. That robot can go inside tanks, external tanks, and a variety of equipment. The drones themselves are excellent. There's a multitude of drones on the market that can perform ultrasonics, dry film thickness coatings, and visual coatings, and each has their pro and cons. Some are made for indoors and work inside very confined spaces and can fly around with little cages so they don't hit anything. Excellent for doing their job, but not so good on the outside of a tank. Whereas on the outside of a tank, the larger drones that have the bigger uh, lift capacities, they can stay still, they can measure quicker, they can perform multiple UT gauges and reflect that down to a digital twin in their program. Uh, Very, very complex units, but easy to use. Just that you have to choose the right drone. If it's inside a small confined space, you have to use that small drone, or if it's on the outside, using the larger drones so that they can handle the wind and other environmental aspects. And then the only other difference that we've seen is the training of using a drone on the outside of vessels. A lot of laws or legal side, you may have to become a pilot to run it, which takes some time and expertise for it. Whereas indoors, you may not have to have that same type of license.
There's something in the what modern technology can do and what it can record. My experience is not so much with the drones. I've seen them. I've seen some of them work. The question about pilots came up a few times. The data they collected when it was able to get done was pretty extraordinary. You could have so much data you wouldn't know what to do with it. Sometimes it's data overload. One of the other things I have been seeing is with some of these cooling robots, the amount of data you want to collect, you can measure surface temperature, you can measure humidity, you can measure air temperature, you can measure airflow, and if you know the speed the robot's working, you can calculate how much paint's been deposited. So you have a lot of records at the time of application, which can then be correlated against what the inspection techniques will be. Work that hasn't been done yet, the correlation hasn't been done, but you can envisage a time when you've got all the data that's come out of a robotic application, then with the appropriate drone going out and cross-checking the film thicknesses and whatever else is needed, then you'll have an appreciable amount of data which someone will have to be able to interrogate correctly to make sure you're getting the work that you want.
Yeah, Jim, along Ian's line, there's some of the crawlers with that voluminous of information. Some of it's so accurate, again, going back to AMPP standards or a third-party inspector. Some of that information we can download to these inspectors, but since they never perform the work or that doesn't meet within the standard, a lot of that information today is wasted. One day that information is going to be injected into the standards where the proof of concept has gone from proof of concept to actually a standard part of this AMPP standard. That process still hasn't occurred today. And so a lot of the robotic companies out there have this technology, but it really can't be fully utilized yet.
Very good, very good. And then when it comes to, we talked about obviously the drones, underwater, aerial and underwater vehicles as well. But for digital inspection reporting, we're seeing that transition has been underway. There have been providers that have developed electronic methods to report, to collect, catalog, report, store, all that type of stuff when it comes to digital inspection of protective coatings work projects and things like that. Those are out there. You can use an iPad, you can use any type of a tablet and things like that to be able to do that. Previous Tuesday, I did a live stream and I covered on the live stream Chat GPT. And then Ian and Norm, before we started the broadcast tonight, we were talking a little bit about, Ian, you were kidding around about the drop in Google stock because, they kind of revealed what their AI strategy is going to be and, to fight against Bing and things like that. But the one thing that I found in the last year, and now even moving with this Chat GPT and artificial intelligence, there is potential that AI could bleed into the robotics side when it comes to surface preparation, coating application, but also for the digital inspection as well.
Yeah.
What are some of your thoughts, both of you, your thoughts, opinions on the future of robotics, and then also to thinking about this inspection and assessment side when it comes to AI and things like that?
The inspection side is the one that intrigues me because some of our structures are going to be there years. The oldest refinery in North America is 120 years old. So when we can get to the position where we can get drones looking at surfaces, reading the surface, and somebody's taking, ChatGI was built up by reading everything on the internet and putting it into whatever algorithms they wrote to be able to give whatever information out. So what industry will need, and someone's going to do it, if someone's taken 2 million pictures on a refinery or 2 million pictures on an offshore platform, and the bits that are corroded, and they start to characterize what that corrosion means, what it looks like, that could be fed into a program. You could send the drone out there to see what the current situation is, and they'll come back and say that area in part B of the plant is due to be painted in 2 years. That part down there will be painted in 4 years. They'll be able to characterize the condition of the plant, the coatings on the plant, what they can see. You can start to see where smart sensors can be used under insulation to start monitoring what might be the condition in the hidden parts. When you've got all that massive data, someone's written the algorithm, someone can then program to something that can take the data from people walking around the plant and picking up the information on a sensor, somebody sending up a drone to collect that information. You can see within reach in the coming easy period of time where that becomes a reality, which will completely change the nature of predictive maintenance and being able to assess and determine what has to be done and when.
Ian, 100%. I believe some of that information is already out in the market today, being trialed. Crawling robots that follow a digital twin, very similar to your house Roomba vacuum unit. These robots are following a digital twin inside tanks on ship hulls, following a path, automated path set out. They're collecting the data, as we earlier discussed, measuring dry film thickness, corrosion cells that are occurring, blistering, and they're collecting it and downloading it onto a digital twin computer. Right behind it, there's going to be small little robots that are coming along, repairing those areas that are injected into the digital twin. They'll say, go to spot 14 and repair that area. And all that information can be captured into one program for the ship owner or the asset owner, a tank or whatever asset they're using. It's going to be digitally kept and for future. And an inspector will be able to come back in 2 years, put the robots down. Please repeat the same path it did 2 years ago. And those robots perform the same path, same measuring techniques, and you're going to be able to measure the variety of corrosion or breakdown of a coating with time, and that you're starting to see now.
I think I agree with you. I think just the depth of data that they've got so far is woefully inadequate. I'm thinking again, chatbot, ChatGI. That was 5 or 6 years of intense data collection. Microsoft threw $1 billion at them for their investment, seed investment. So the amount of data we've collected so far is a good start, but I still think it's woefully insufficient. And I think some of the interpretation algorithms, there's going to be a lot of discussion on them, because if you see a point of corrosion short of 3 people, they'll probably come up with 3 different answers. So the amount of work that's got to go into making sure the algorithms can actually align with what they're seeing against some type of appropriate standard. And rightly or wrongly, some of our owners around the world use different standards on when something should be painted and not painted. So there's work to be done. There's algorithms to be written. There's tweaking to be done for specific owners. The marine shipbuilding world is probably a good one to start, because ships are pretty uniform. They're not as complicated as some of our industrial structures, but somebody will put the money in, somebody will collect all the data, someone will do the hard work interpreting the data, somebody will write the algorithms, and we'll have it fed into all the appropriate things. So what's going on, Norm, but I just think we're at the cusp of getting the data.
You are, and as you mentioned, I think a lot of robotic companies out in the market won't invest in that, because if an owner won't accept that information because they look down and looked at their third party and say, "What do you think?" and he says, "Well, it doesn't fit within my AMPP standards," a lot of that information is going to be wasted. And
Yep.
I think we have to get back to trying to get the owners to put pressure. Hey, we want these standards changed. And as we first talked about at the beginning of this program, that's where we actually have to go to our standard organization and say, we want to be able to come up with robotic standards that can gather all the information that humans aren't. Like you say, we're not visually looking at it; they're electronically looking at it. We're not doing DFTs using our hands. We're using DFTs to follow an SPPA2 program. So that information has to be quantified, qualified, and then as it's downloaded, the owners have to be able to accept it for what it is, rather than questioning it, saying, well, it doesn't meet the standard.
I've got this written down in my notes to myself. Change is usually pushed, and that's got to come from an owner, as somebody who realizes they've got to make something changed. It's got to be driven by passionate people, and it will need a lot of investment to collect all the data. In the end of the day, someone's then got to have a business model that works, that actually delivers something with an appropriate value proposition that is adopted across the industry. So we have challenges because we're a pretty industry's pretty fragmented. Owners have different impressions, but somebody with the right investment will collect the right amount of data. Only needs one owner to pick it up, and then the rest of the industry will take notice. You need that leader to make the change. Once the change is happening, that's when the owners will adopt it, and it'll start getting its own life. But I think we're on the cusp of this, but we're not there yet.
Yeah, Ian, you're 100%. The owners specify it, and it'll happen, and you get that one big player.
Yes,
maybe
that's
it's maybe it's some big military side, or a big owner in an industry. Yeah, they make the change. So in the audience right now, we have several great professional inspectors that make a good living off of coatings inspection. So I guess a question I have for you two, but also too for the audience as well, and you can raise your hand and jump up on here. When we're looking at all of the artificial intelligence, we're looking at all the machine learning that's going on. We're seeing revolutionary changes that are happening, not only when it comes to surface preparation and coating application, but also related to inspection when it comes to the ability to use an iPad or a tablet to be able to do it, all the electronic stuff. What type of caution, what should we be concerned? Because, one thing I would throw out there, my concern is that AI creeps into the coding inspection side, the AI can interpret a standard probably a lot faster. But I do know that people who are experienced inspectors are great with standards and everything. But to the point you guys made earlier, there's so many data points, and AI is going to be able to go through that faster than a human can. Is there any threat to the human coatings inspector from a machine doing the coatings inspection?
I would think probably not, because the number of projects that we do in the world is probably not going to change substantially. You got a 20% improvement in productivity because of what you can do. There's still going to be an amazing number of projects which are going to be inspected, they're going to be documented. Now, will the skills have to be different? Probably. Will some of the what the roles and responsibilities are? Probably. But the emotional intelligence of an inspector to be able to interrelate with the contractor and the owner, that's not really going to change. But I certainly would see if you look back a couple of decades out, the skill base of some of the inspection work will be probably completely different.
I think along Ian's line, I think the skill set's going to change, Jim. I think inspectors are going to, again, very similar to abrasive blasters and coders, it's a shift. Rather than going to perform the work, they'll be operating an inspection robot. They'll be gathering and using that data to create the reports. Now, some of those reports might be automated. Some of them are automated now. So taking that information, being able to give better information back to the ownership, and also being able to inspect areas that are hazardous, radiated areas, ship hulls, ballast tanks, things that were places where inspectors need to go inspect but really don't want to inspect, now can do it safely. They still have their job, they're still getting paid well, but the information is being able to be transmitted either in live form or in a very, very quick, effective form.
Yeah, I think really if you get involvement of the certifying agencies, the standards organizations, they can kind of be a counterbalance between what is developed and kind of maintaining that human AI type of collaboration. So, well, if anybody has any questions for Ian or Norman, just raise your hand. I can bring you up on the stage, but we have about 5 minutes left. If not,
Yeah. While you're waiting, Jim, it's just
anything closing.
we can talk about these things that we see in the future, but how close is the future? Some of these some areas we'll move quicker, some areas will be slower, but you're going to be talking in my mind into decades before we see the radical shift here because of the fragmented nature of our industry. Could be wrong, but I'll still say there will be change, but I don't see it happening at the speed that we've seen other things change.
Yeah, that's a good point. All right, let me bring you up on stage here, and let's see here. All right, just unmute yourself, and you can ask a question or add a comment.
Hey, I'm Shell. We actually did some robotics about 5-6 years ago. We're in the subsea pipeline business. We actually had to abandon the technology because of the lack of manpower. Because obviously, once a robot goes down, a normal operator can't just fix that robot. So our major problem was getting competent people in troubleshooting these robots. And this would obviously also be all around the world in remote locations and offshore. So the technology worked, but it did not seem right for the industry at that time, which I think might be possibly still a problem, that you have to have very advanced technicians on site to be able to troubleshoot these things.
You can do. I mean, it's the point I was making before. A business has got to be sustainable. It can't be a one-off. I've seen in the oil industry in your subsea areas some of the deployment of some of the subsea tools and some of the subsea electronics, but it's been big business that's been able to support it. I think that's going to be one of the issues with the robotics. You've got to have knowledgeable people in place. Now, one of the things I have seen that's happening, certainly with some of the robotics I've been interested in, with the things like VDU glasses, they've had technicians in one part of the world with the glasses on, working with the lead technicians in other parts of the world, showing them how to fix it. So they were actually working together live, where the really experienced technician could see what the technician on site was seeing. And that is something that was done recently on a project between Holland and Singapore. So there is ways to do it, but it's got to be built into the business. It's got to be built in the protocols, and it's got to be sustainable. Because if it's a one-off and it fails, the business case is gone.
Absolutely, Kajil. Good point on your robot. So I believe strongly in the next couple of years there's going to be these training portals around the world, such as Singapore, Houston, Eastern USA, Amsterdam, mid Europe, where companies can come and get trained in a variety of robots. But like Ian said, for our company, we have a training AR program where we can train people using our robots, using AR programs. And if you're on a job site, you would have one of these helmets. If you're having issues or we need to train more people, we can do it online, and I can do it 5,000 miles away. That as Ian mentioned, if we don't have that, it causes a lot of problems both for the contractor and the robotics companies.
No, I agree, and we've used the Hololens, for example, before. Our ace is of course in remote locations in West Africa offshore. There's not really an internet connection suitable to deal with this kinds of stuff.
I think on large jobs like that, it's going to have to be the contractor and the robotic company working together to have backup training, backup support for especially large key critical path projects.
And there's also got to be the situation where the ability to say no. I mean, some of these robots are going to develop in the large industrial areas where there's plenty of opportunities. There's 800 large dammed storage tanks painted every year in the USA. I don't know how many ships are dry docked around the world in some pretty sophisticated locations. Some people are going to have to say, if you come along to us and say, I've got a project in the oil fields in Chad, sorry, we're not ready for that yet. It's hard to say no, but sometimes you have to say no because the expertise will grow, but it's going to grow where you've got critical mass.
Agreed.
Okay, we're about 2 minutes to the top of the hour. Ian, how can people get in contact with you?
At the moment, just hit me on LinkedIn. I read it all the time and look at that, and I'll be back in touch with other phone numbers or emails.
Excellent. And Norm, how can people get in contact with you?
Same thing. I'm on LinkedIn or spencecorrosion.com. I have my contact information there, and if you email me or link me, I'll send you my contact information right away.
Perfect. And then everybody, you can communicate with me through LinkedIn. This recording, what I'll do is I will process it and get it up within 24 hours. I'll post the link on LinkedIn. It'll be available on the Codings Talk YouTube channel. And if you have any recommendations on topics, either for live chat or for live streaming, you can email me at jim@jimkunkel.com. Thank you, everybody. Have a great rest of your night, morning, afternoon, wherever you're at. Have a good day. Thank you, everybody.
Thanks, Jim. Thanks for the opportunity.
Thanks, Jim.